Hello, welcome to our presentation. I am Muhammad NUBLI bin Muhammad HISHAMMUDDIN, metric number 01 DKM5B. In this presentation, we want to share about the procedure for gas power plant in gas turbine. Gas turbine or combustion turbine is a kind of continuous flow internal combustion engine. Its upstream compressor is a pair with one downstream turbine, and combustion chamber is located in the middle of it. The main part familiar to all gas turbine engine, from engine producing part known as gas generator or corer, and down the flow is rotating compressor gas, combustor, compressor, and compressor drive turbine. Energy is added to the gas flow inside the burn, where air is mixed with the fuel and burn. Combustion will increase the temperature, speed, and volume of the gas flow. It will directed to the nozzle through the blades of the turbine, twisting the turbine and turning on the compressor. Energy are obtained in the form of shift power, compressor air, and thrust in any combustion, and is used to power aircraft, railway, ship, generator, and even tank. Additional component need to be added to the gas generator to switch its application. Common to all air inlets, but with a different configuration to meet the need of a marine use, ground, or flight use at the speed varying for stationary to supersonic. A fan nozzle is added to create thrust of flight. Next, I want to invite Lee Jin Hong to continue our presentation.
Thank you, NUBLI. My name is Jin Hong, and now I would like to continue the presentation with the working procedure of the gas turbine power plant. Gas turbine is an internal combustion engine that uses gas as the working fuel. It extracts the chemical energy from the fuel and converts it into mechanical energy, and this energy is used to drive the connecting shaft of a generator. At the beginning, a large amount of air is supplied to the gas turbine engine to provide necessary power. The air supplied must be clean to help to extend the engine life by preventing the erosion or corrosion to the engine or any foreign object that may cause damage to the engine. This may be achieved by pass the air through the filter before the air entering the compression chamber of the gas turbine engine. The second process is compression. The compressor is responsible to compress the air to a high density, which helps to accelerate the fuel combustion in the combustion chamber. The compressor draws air into the engine, pressurizes it, and feeds in hundreds of miles per hour into the combustion chamber. This process involves transforming of the kinetic energy of the air into pressure energy. Then the pressurized gas will enter the combustion stage. A combustor is a place where the fuel burns in the presence of air. Usually it consists of ring or fuel injector that continuously supply the gasoline into the combustion chamber. Then the combustion chamber will ignite the air-fuel mixture, and over 2000 degrees of Fahrenheit of temperature will be used to burn the mixture. The gas stream that enters and expands through the turbine portion that created by the combustion chamber has high temperature and pressure. This helps to increase the velocity of the gas stream, which is necessary for the turbine rotor to develop power. After that, the combustion gas will enter the turbine section of the gas turbine engine, which is responsible to produce the useful output shaft power, which used to drive the generator. In addition, it is also responsible to provide power to operate the compressor in order to bring in more air for the operation. It does this by expanding the high temperature, pressure, and velocity gas and converting the gaseous energy into mechanical energy in the form of shaft power. The turbine blades rotate as the gas expands through it. The gas turbine engine shaft has a generator attached to it for electricity generation. The turbine delivers the mechanical energy to the generator and transforming it into electrical power. While the exhaust gas, which include the waste energy that escape from the turbine engine, which can be reused for external purpose, such as turning a second steam-powered turbine engine, which attached to another electric generator, in order to increase the efficiencies of energy generation. So that's all from me. Now I would like to hand over to my groupmate to continue the presentation.
Okay, thank you, Lee, for giving me a chance to continue our presentation today. My name is HUSAINI by AZMI, and my matrix number is 010120F DKM5B 10 and 72. Now I will continue. My part is about HRSG. Okay, a heat recovery steam generator is an energy recovery heat exchanger that recovers the heats from a hot gas stream such as a combustion turbine or the waste gas stream as we know. Okay, it produces a steam that can be used in a process that we call cogeneration, or we can use to drive a steam turbine which is in a combined cycle. Now, for working procedure, I will explain the step by step about the working procedure of the HRSG, which is a heat recovery steam generator. Okay, for the first one is the water and the hot gases are separate by the solid boundaries of the pipe material, which is the water and the hot gas come from the pipes that connected to the steam generator. And the second one is the second process is the pipes are provided with extend fins in order to increase the effective heat to the transfer area. And the third step is the water is first passed through the economizer, from where it passes through evaporator that the which is the main component is the on the steam generator HRSG's principle, working principle, and then it go to the superheater, the hot gases and also the water. So that is the procedure of the system generator that I present today.
Thank you, Irfan. So I will be presenting about the condenser that commonly used in power plant industries. In thermal power plants, the purpose of a surface condenser is to condense the exhaust steam from a steam turbine to obtain maximum efficiency and to convert the turbine exhaust steam into pure water. So it may be reused in the steam generator or boiler as boiler feed water. For the work principle, firstly, I will talk about how to steam flow to the condenser after turning the turbine. Low pressure and temperature steam from steam turbine enter the condenser, which is below the atmospheric pressure. The inside pressure of condenser is below atmospheric pressure. Due to different pressure, the vacuum occurs and the steam flow the way to the condenser. After the steam enters the condenser, the cooling water that circulates in the condenser will extract the heat from the steam. In that time, an energy conversion occurs, causing the steam to turn into a liquid. This process is called condensation, or can be simplified, the process that converts gas to liquid. Cool water that was pumped from lake, river or other source will fill the tube in the condenser as a cooling medium. The different temperature of the steam and the surface of tube will convert the vapor to liquid, which is pure water. The condensate substance then will be collected at the bottom of the condenser. After that, the condensate extraction, which is pure water that has been collected, will be pumped to the low pressure preheater. Low pressure preheater will preheat the water to reduce time taken of the hot well water to convert into the vapor in the boiler. Then hot well water will be pumped to the economizer and then to the boiler. This cycle will use the same substance, which is pure water, repeatedly as a cost-saving method.
From studying this subtopic, we know that the gas turbine power plant provide many benefits to users. We must be grateful for the ingenuity of the engineer who have created this system. This gas turbine is widely used to power aircraft, trains, pump, ship, electrical generator and tanks. This system has 5 major advantages. The first is that it imposes a lower operating cost compared to low carbon emission alternatives like nuclear and renewable energy. Gas turbine power plant also have high efficiency and durability. Besides that, it has the advantage of facilitating distributed power technology, which is quite flexible and can operate both standalone and as a part of integrated system. For the sake of environmental sustainability, the system is environmentally friendly. This system also has a high operating speed and low lubrication costs, help lower operation costs and provide better service in less time. Last, as a student who study and learn this system, I feel moved and proud of the existence of this good and useful system for the benefit and use for human. With this, we get a lot of knowledge related to the gas power plant system from this study case.